Hello students, today we will be going over 9.1, Interpreting Statistical Plots. Our objective, I can compare measures of spread, IQR and standard deviation. Our vocabulary, symmetry, a distribution that is approximately symmetrical about the center. And we'll be given some examples of that. Uniform distribution, a symmetrical distribution that looks rectangular. Standard deviation, you'll see that little weird thing like that for standard deviation right there, or the capital S, a value that summarizes how far data values are from the mean. So in other words, it's the spread of the data, okay? So we're going to go over a few examples here. Here's one graph. It's symmetrical because if you draw the shape over the outline of the bars, like that, it's bell-shaped, okay? This is symmetrical and also bell-shaped. So it's approximately like X bar is about the same, or the median, that's what that is, the median, oh, that's the mean. So the mean is 5.5 the same. Median, it's when the median and the mean are kind of close together would be symmetrical, okay? This next one is symmetrical uniform. And again, it's a symmetrical distribution that looks rectangular. That's this one, where they all could be just a plain rectangle. Now, in reality, you can have one of these higher, one of these a little bit lower, but all in all, uniform, symmetrical is going to be looking like it's a straight rectangle, okay? Here is a U-shaped, it's symmetrical, but it's not like a bell. It's like an inverted bell, so it's called U, see, like a bull, so you can think of U-shaped, okay? This is bimodal. Symmetrical means there's two modes, which means there's two towers. You think of it as two buildings next to each other, okay? And this is also symmetrical and bimodal. See, the two can be at the end rather than the middle. So you can notice that the standard deviation is higher because the data is further spread out here. And this is also, the data is closer together, so this standard deviation is a little bit lower. Now it says describe the relationship between the mean and the median for symmetrical distribution. So the mean right here and the median, guess what? They're close to being the same when they're symmetrical. See here, mean, median, mean, median. These are all 5.5, but they're shaped totally differently. However, the mean and the median are close to being the same. So we would say when the X bar is the mean, is closer, almost equal to the median. That's what happens when it's a symmetrical distribution. So you can say mean and median are almost the same. And the next question, what causes standard deviations values to increase? Okay, so it's when more data is further from the mean. So if you have a bell curve like this, the mean and the median are close. But if you have something else where you have data and then hardly anything and then more data, the standard deviation is further apart than this. So this one This standard deviation here is going to be less than, because the data is closer together, than this standard deviation on this one. So this is standard deviation. I think it's called theta for Greek letter. But just know that it means standard deviation. And we'll go over a few more on that in just a minute. Okay, the next one on page 161, we're going to go over positive skew and negative skew. Positive skewed means skewed right, and that's what the data looks like. It just means fewer observations on the right. In a distribution with positive skew, the mean is greater than the median. So for positive skew or skewed right, you want to put the mean is greater than the median. Okay, circle that on your paper. Okay, if it's negative skew or skewed left, we're going to say the standard deviation is less than the median. Okay, why is it called skewed left? The mean is pulled to the left of the median. Mean is pulled to the left of the median. And why is it skewed right? Mean is pulled to the right of the median. Okay, the main thing to remember here is that there's less data on the right-hand side, less data on the left-hand side. So the mean is pulled to the left of the median. Here the mean is pulled to the right of the median. And that is why. Okay. And we're moving along. You might have to pause the video. What information is gained through measures of center? Helps us know where the middle, and you should be writing this down, and I'm going to put that in little quotation marks, middle values of the data set are. Okay, and what about measures of spread like standard deviation? It helps us know how well the mean represents the data. Okay. All right. Next, we're going to go to graph 1 and graph 2. You can pause the video if we need to, but I'm needing to move on because there's a lot to cover here. Okay. Page 161 at the bottom, graph 1. Now, I'm just going to draw an outline of all the data. Okay. So, and this one is more like that. Describe the distribution. That's kind of a bell, so I'm going to say it's symmetrical. And as symmetrical, I'm going to put bell. Same with this one, symmetrical and bell. Okay, so if it's bell-shaped, then usually the mean is about equal, and if you do squiggly equal signs, that's approximately equal. And the same with this one. Compare graph, the standard deviation on the first one and the standard deviation on the second one. Okay, so here most of the data points are within here. This is a lot more spread out. So this standard deviation is going to be bigger than this one because these are all graphed together or like close together. So we would say this one is less than, the deviation is smaller because they're closer together than this standard deviation where the data is all spread out. So remember, standard deviation means how spread out the data is. Okay? All right. You can pause it if you need to. One last one here. Okay, right here. Okay. Now you have graph 1 and graph 2. This is page 162. Now we're going to describe the distribution. Is it centered? No, that one's not central, so it's not symmetric. Okay? And more of the data is on this left-hand side, so less data over there. So it's skewed right on the first one. So skewed right. Whereas the second one, that it looks like it's kind of in the middle, so that one's going to be symmetrical. Can't quite tell if it would be a Bell figure or not because I don't have all the data. Okay, so if it's skewed right, the mean is what compared to the median? If we go back to our skewed relationships here, we go, oh, skewed right, that mean is greater than the median, so that's what we write. The mean is greater than the median. And it's symmetrical, it's approximately equal. Now we compare the graphs. Oh, I forgot to write median 1 as compared to median 2. So they're talking about this line in the middle. There's the median there. So this one is going to be less than that one. Okay. And the standard deviation is also going to be less than here. See how this data is way spread out? And this is together here. If I move that over to here, this one's more spread out. So this standard deviation has to be less than the other standard deviation. Okay, that's a lot, students, but I know you can do it. You rock.